Hello, my name is Colby Royer, and I will be presenting my team's overview presentation for our submission in the 2023 Geothermal Collegiate Competition. Our team is the Colorado School of Mines, and the name of our submission is Blaster's Geothermal Solution. To begin the presentation, I would like to introduce the team that put their effort and dedication into this project throughout the semester. We had myself, Colby Royer, we had Geneva Loff, Nicholas Ferguson, Trenton Bledsoe, Ballner Mindy Galieva, Julian Golick, Ryan Cockrell, Holden Drew, and Hayden Ray. So the Colorado School of Mines is a rigorous engineering school, and all of these students took time out of their busy schedules to come up with this geothermal district heating and cooling solution that we believe is innovative and capable of benefiting our community here in Golden, Colorado. So our team ranges from undergraduate sophomores all the way to PhD students, and our faculty advisor was Dr. William Fleckenstein from the school's Petroleum Engineering Department. The team met on a weekly basis to ensure progress is being made on our solution, and we even had the opportunity to get hands-on experience through multiple tours of the campus's existing facilities and even the new geothermal infrastructure currently being installed. So the photo on the right shows the team after a tour of Beck Venture Center and Parking Garage 2, where we got to see active drilling of vertical geothermal wells, trenching, pipeline operations, and then finally the heat pumps inside the new buildings that are under construction. To add on to a little bit more of who we are as a team, we are incredibly diverse and multidisciplinary. We had 11 team members, and amongst those 11 team members, we came from 6 different engineering disciplines at our school. These disciplines were mechanical engineering, electrical engineering, petroleum engineering, geological engineering, materials and metallurgical engineering, and then finally engineering and technology management. Our faculty advisor, Dr. Fleckenstein, has years of experience in geothermal, ranging from roughnecking in the Salton Sea all the way to developing some of the latest enhanced geothermal systems technology. One of these includes a method to hydraulically fracture and then have fluid conformance control, which is titled Geotherm Optimal. Lastly, just to note our vision as a team this semester, it was most importantly to push for geothermal on our campus. New buildings are seeing geothermal district heating and cooling installations, but what we believe is that these old buildings could be given the same solution. So here's our project summary slide. Over the course of the semester, our team conducted research and met with various industry professionals, companies, and college departments to identify the potential for geothermal district heating and cooling on the Colorado School of Mines campus. Through this, we identified 3 buildings already connected to a chiller plant loop, which would then be capable of conversion to a closed ground loop and ground source heat pump system. So these buildings are the Volk Gymnasium, Arthur Lakes Library, and Guggenheim Hall. Our proposed project's key idea is that these buildings can be augmented with a GDHC system using the pre-existing infrastructure. So the goals of the proposed project are to drill 30 vertical geothermal well bores and a closed ground loop system to replace the existing chiller plant system with both heating and cooling capabilities now. This would increase efficiency and also inform our students on campus in the various engineering departments while doing so. So the implementation of this proposed project would foster growth for geothermal on campus that is already beginning to utilize it for heating and cooling. And it also presents an opportunity to change from a less efficient chiller plant system. And then lastly, it would just have the opportunity to teach students in our academic departments and allow them to contribute more than we are seeing with the current installation of geothermal infrastructure on campus. So now let's dive into the real-world problem which makes our proposed solution relevant. District heating and cooling often uses coal or natural gas, and this use of fossil fuels and a release of greenhouse gases ultimately damages our planet. Heating and cooling are a major factor, not just for residential homes, but especially for larger communities such as colleges, campuses. And this presents an enormous opportunity to make these practices more sustainable. Thankfully for our team, the Colorado School of Mines pushes greatly for the sustainability of its buildings. And this has allowed us to identify the problem with our energy usage and come up with the solution. Specifically, the problem we identified was at one of the chiller plant stations, which was chiller plant 4. This plant has been in use for over 20 years and the school is already looking at replacing it. This presents a real-world problem for simply replacing it with another chiller plant or looking at a different technology such as GDHC. Next, there is the issue of grid dependency and outages. Firstly, the grid is not carbon neutral, and secondly, outages are sometimes seen. Just this semester, actually, our campus had an outage from Xcel Energy and was forced to use generators in order to power campus. The last scenario or problem to note is the Mines at 150 initiative. As a result of the school turning 150 years old, the Colorado School of Mines is looking to expand its student body and opportunities. With this, that means new buildings and infrastructure have been coming on campus recently. These new buildings will need a source of heating and cooling, which is where GDHC can really come into play. The solution our team came up with for all these problems that we noted on the last slide was different than looking to newer buildings and infrastructure on campus. Although the new construction is actually utilizing geothermal heating and cooling, our team went a different route with our solution and opted to look for a way to augment older buildings with a GDHC system. Currently, cooling on campus is done by chiller plants, which service groups of buildings, and our team identified and found data on Chiller Plant 4, which, as noted, has been in commission for over 20 years and services the Volk Gymnasium, Arthur Lakes Library, and Guggenheim Hall. These chiller plants have no heating capability, and heating currently comes from a central steam system. With the addition of a geothermal ground loop, our team proposes a way to combine heating and cooling in one sustainable and efficient system. Our technical analysis and conversations with all of our stakeholders this semester have led us to the conclusion that approximately 30 vertical well bores would be needed for our system. These would have a diameter of approximately 6 inches at a depth of around 600 feet. We have also identified a heat pump that could be used for our system with the design coming from Sustainable Energy LTC. This water source heat pump model is rated for 545 kilowatts or 140 tons, which is above the expected demand from our analysis of the current energy usage. Our team has also identified the possibility for distributed heat pumps. What's special about these is that they bring the added benefit of being able to control the climate of specific rooms in these buildings with controls and user interface coming from the heat pump manufacturer. This technology is actually what we found to be installed on some of the new buildings under construction, and we got to see that on the tour. So lastly, to close out this presentation, we would just like to highlight some of the real-world benefits to our community that this proposed solution would bring. The first and most obvious is environmental sustainability. Geothermal heating and cooling is virtually emissions-free, and the buildings connected would no longer have any need for natural gas or other fossil fuels that power the grid. In the long run, our campus would also see cost savings. These cost savings come from no longer needing to pay for third-party service providers such as Xcel Energy, and these savings would become prominent after paying off the initial investment for the wellbores and ground loop. Next, these buildings would have year-round, reliable, and efficient heating and cooling that is no longer dependent on other factors. Our team also pointed out the opportunity for educational opportunities as a benefit. Just because the geothermal collegiate competition comes to a close does not mean that the knowledge sharing on this technology has to come to an end. A project like this, if incorporated with the school's many engineering disciplines, could serve as a way to teach critical engineering topics and the importance of sustainability at the same time. Finally, as a school whose slogan is Earth, Energy, and Environment, this step towards greater sustainability with geothermal district heating and cooling would benefit the school's public image and hopefully help to gather more donations from alumni and other investors who see our community taking steps in the right direction. Thank you for listening to this presentation, and I hope you enjoyed learning about our team's geothermal solution here at the Colorado School of Mines.